the question posted by our Aishwarya. Let us clarify her doubt first before going into the lesson. She asked me the question that find the number of ways of placing 3 letters in 5 letter boxes so that all the letters will not go into the same box. Of course, I have modified her language what the question is given is the meaning of that is same. There are 3 letters and 5 letter boxes, and previously I discussed the same. If the letters and boxes are there, with repetition of permutations, we have derived with repetition. Permutations with repetition, we have derived this formula in the previous classes n power r. Generally, what the doubt is posed by the students is this: which one is to be taken as base and which one is to be taken as the power? It is very simple. Generally, in this type of questions, generally the fixed one should be taken as the base and the variable one will be taken as the power. In this case, generally the letters we have to take to the boxes, but the boxes will not come to the letter. So in this case, what you have to do, the boxes are fixed and the letters are variables. So it should be 5 cube. It should be 5 cube. But here the restriction is all the letters should not go into the same box. What does it mean? This is 5 letter boxes and 3 letters. All the 3 letters can be posted in should not be posted in the same letter box. How many letters are there? 3 letters. 3 letters can be posted here or in the second one or in the second one or in the third one or in the fourth one or in the fifth one. So how many cases will be there? How many cases will be there such that all the 3 letters will go into the same post box? Either they will go into the first post box, or that may go into the second post box, or that may go into the third post box, or all the 3 can be going to the fourth post box, or all the 3 can be posted into the fifth post box. So how many cases are there? 5 cases are there. We don't need those cases because the restriction is all the letters should not go into the same letter box. That is why 5 cube minus 5 is the answer. 5 cube minus 5 is the answer. I hope, Aishwarya, you might have understood this. Okay? And keep on posting your questions like that, and you can post your doubts or you can mail your doubts to, you can see that on the screen, that is on the slide. It is info@cabtv.net. Okay, keep posting on your doubts like that and we'll be clarifying all your doubts. Thank you, and let us now go to the session. Yesterday we have discussed, we have derived the permutation formula with repetition or without repetition, and of dissimilar things and also similar things. When like things and dislike things are there, what are the principles to be followed, and all these we have discussed in the previous session. Now let us see today the circular permutations. What is the difference between a linear permutation and a circular permutation? Linear permutation, linear permutation is nothing but a permutation which is arranged in a row. That means for a linear permutation you will have the beginning and you will have the ending. That means if you take any row, if you take left side as the beginning and the right side will be the ending. If you take right side as the beginning, left side will be the ending. That means in a linear permutation you will have both beginning and ending. Then in a circular permutation, what is the difference between a circular permutation and a linear permutation? In a linear permutation, as I said, you will have the beginning and ending. And in a circular permutation, you will not have any beginning and ending because they are placed circularly, like this, for example. So in this case now, what should be the number of permutations when they are arranged circularly? So that is, when you take n things. When you take n things and n things are to be arranged in a linear manner, that is in a row, then you know by taking all at a time, it is npn, which is nothing but n factorial. Which is nothing but n factorial. What does it mean? N things permuted by taking all at a time. But all these n things, you must remember, are dissimilar things. When n things taken r at a time, it is denoted by npr. Totally, there are n dissimilar things. From n dissimilar things, we have taken r things. And for this one, we have derived the formula yesterday, that is n factorial upon n minus r factorial. Okay, this is for a linear permutation, understand. But what should it be for a circular permutation? And the basic difference, what you have to understand is that for a linear permutation, there will be beginning and ending. For a circular permutation, there is no beginning, no ending. So, whenever you take n things that are to be arranged circularly, imagine there are 5 students of you and your friends. Together, there are 5, and you 5 are sitting in a round table. And if you sit in a round table, if some other person comes and if he sees, he doesn't know which is the beginning and which is the ending. How many persons we have considered here? 1, 2, 3, 4, 5, 6. Only five persons, let me say 5 persons. And first person, second person, third person, fourth person, fifth person. You are sitting on a round table. You are sitting on a round table. Then, which is the beginning here, which is the ending? You cannot take this 1 as the beginning. Because just for the sake of the numbers, I have taken like this. Let us change it. Otherwise, x1, x2, x3, x4, x5. Or PQRST, whatever you like, let us take like that. Then we don't know the beginning and we don't know the ending. Then what we do to arrange these 5 persons circularly, we will fix up a person. And he will be the beginning and he will be the ending. Then we arrange the remaining people. So here you have 5 persons. Among 5 persons, we will fix a person and we arrange the remaining. So it will be 5 minus 1 factorial. Understand? If it is linear, what should it be? x1, x2, x3, x4, x5. What should it be? Linear. You have beginning and ending. That is why there is no problem at all. It is nothing but 5 factorial, understand? Which is nothing but 5p5. But circularly, it is not 5 factorial, but it is 5 minus 1 factorial. What for this minus 1 stands? Because you don't have any beginning and ending like this in a linear permutation. You fix a particular person and you have to arrange the remaining people. That is why it is not 5 factorial, but it is 5 minus 1 factorial. Similarly, if you take n things that are to be arranged circularly, n things that are n dissimilar things that can be arranged circularly is nothing but n minus 1 factorial. So if you see the slide there, the second point, the number of circular permutations of second point please, the number of circular permutations of n different things taken all at a time is nothing but n minus 1 factorial. That minus 1 stands for the particular person which is to be fixed for beginning and ending is nothing but the minus 1. So it is not n factorial but n minus 1 factorial. Very good. Then what should it be if n persons are there and r persons are taken or r things are taken? In this case, n are there, all n are taken. In that case, all n are taken, it is n minus 1 factorial. If n persons are there and only r persons are taken, then how many circular permutations will be there? Very simple. Follow this carefully, please. Let us suppose, let X be the required number of circular permutations. What does it mean? By taking R persons from N persons, and these R persons are to be arranged circularly, then we don't know how many arrangements will be there. So we have considered that as X. That means the required answer is X. The required answer is X number. From X number, what I do, I'll consider one circular permutation. Consider one circular permutation. What does it mean? Your required answer is X, and from X I have taken one circular permutation. In one circular permutation, how many things will be there? How many things will be there, or how many persons will be there? There will be R persons. That means X1, X2, X3, X4, so on, XR minus 1, XR, let me say. So, in one circular permutation or arrangement, you will have totally R persons or R things. Okay. Now, my interest is from one circular permutation, how many linear permutations can be made? Hello?
Hello?
Yeah?
Sir, you told that we have to, in circular permutations, we have to fix one person and we have to arrange all of them, right, sir?
Yes.
Hello?
Yes, please. I'm hearing. Please continue your question.
So, why have to fix that one person in this?
Yes.
In circular permutation, we don't have beginning and ending also.
Yes.
Why we have to fix one person and we have to arrange all of them?
That's what you must understand, the difference between a linear permutation and a circular permutation. In a linear permutation, what happens? You will have, let me say, this is beginning and so on, this is ending, isn't it? Now, in the beginning, you will begin arranging the things from this place. And we have already seen it through the principle of counting. But in the circular permutation, what happens? You don't know when these things are arranged circularly, you don't know where to start first to arrange the things. That is why you can fix any one of this. Then if I fix this as the beginning, you can take any one of them. If I fix this as the beginning, then here it starts, here it ends. And thereby we are keeping this person fixed and the remaining are arranged.
Okay.
That's it. You understand?
Yes, sir.
Okay. Then coming to this. Now, a circular permutation, if I take one circular permutation, then one circular permutation contains R different things. Now, my interest is, from one circular permutation, how many linear permutations can be made? You think of it, please, carefully. That means, I'll take an example. Like, 5 persons are there. Let me say P, Q, R, S, T. 5 persons are there. They are sitting on a round table. Now I want to know, from one circular permutation, how many different linear permutations can be made? Then what I do, I will break the chain here. This is 1. I will break the chain here. This is 2. If I break the chain here, this is beginning, this is ending. If I break the chain here, this is beginning and this will be the ending. And if I break the chain here, you can understand this will be the beginning and this will be the ending. Like that, if you break the chain, In how many places you are getting the breaking here? This is 1, 2, 3, 4, 5. That means if 5 persons are seated on a round table on a circular permutation, then how many different linear permutations you are getting are nothing but 5. For 5 persons it is 5, for 6 persons it will be 6, for 7 persons it will be 7, for R persons, understand please, for R persons how many linear permutations can be made from one circular permutation? You can break the chain here, you can break it here, you can break it here, so totally you will be getting R different linear permutations. Understand that. So each circular permutation is leading to R linear permutations. Then one circular permutation gives you R circular one circular permutation gives you R linear permutation. Second circular permutation also R linear permutation. That means for first R, second also R, third also R, so on. So on. How many you will be getting? How many? What is your answer here? How many number we have taken? X, no? So that is why it is X times. So it should be R into X. R plus R, 2R plus R, 3R plus so on, X times added, it is R into X. R into X, now which is equal to n factorial. Why n factorial? It is nothing but the number of linear permutations is equal to n factorial. Now it is n persons taken R at a time. If it is n factorial, we have to take all the persons. But here we have taken only R persons. So it should be NPR. So it will be X is equal to NPR upon R. Understand? So what is our learning here? When all the persons are taken, it is n minus 1 factorial. When R persons are taken, it is NPR upon R.